Okay, good morning, class. So today we're looking at probability. So third lesson dealing with the counting principle, okay? So today we're looking at arrangements of objects in a row. Arrangements of objects in a row. This is, for example, 3 on page. So exercise 3, which is, exercise 3 on page 15. However, this example we're looking at, which is example 10, is on page 313. The same page as the exercise. 315, okay? Alright. So arrangements of objects in a row. So you say we did a geramstaf, more geramstaf happening now, no? So in example 10 we are told, in how many ways can 3 boys and 2 girls sit in a row? Yes, that's what makes it geram, no? They're not brothers and sisters, they're family and... Right, so let's go. In how many ways can 3 boys and 2 girls sit in a row? How many bits do I draw? 5. Why? 3 boys, 2 girls. Okay. So it's 5 people in total. They're not going to share a seat. No, they're not going to people. 1, 2, 3, 4, 5. So how many options do I have for the first one? 5. Why 5? Was there a condition that the girl needs to sit first? That a boy needs to sit first? So if there's no condition placed on the question, then it's a straight, your options is fair, okay? It's even. So it's 5 then, 4 then, 3, 2, 1. Which is? 5 factorial, which is?
Report to the office.
1, 2.
Les Iveco, grade 11, can you please report to the office?
5 factorial, huh? 120, absolutely. Okay. Right, B. In how many ways can they sit in a row if a boy and you see the garam? If a boy and his girlfriend must sit together? Huh? So let's go. B. How many seats are there? 5. 1, 2, 3, 4, 5. Now, this boy and his girlfriend, let's put them here. Boy and the girl. No? And we bind them. Wait. Before we bind them. No? The boy and the girl sit here. Okay? They must sit together. Okay? So, we bind them. Okay, so they must sit together. Alright. So how many ways can they sit in these 2 seats? 2 factorial. Not so. Why? Because the boy can sit first or the girl can sit first. So how many options do I have here? 2. Then 1. That is why it's 2 factorial. You all agree with that? But you say, hang on, what's the condition that they need to sit in the first 2 seats? No. So what other option do I have? They have 1, 2, 3, 4, 5. So they can sit here as well. The boy and the girl. We bind them. I say, hang on, they can sit in seat 3 and 4 as well. Okay? The boy and the girl. Okay? But actually they could sit in the seat 4 and 5 as well. Not so. So they can sit in It's a day as well. So how many? If we now look at, actually I have to explain this part first. But okay, how many options do I have then? If I take this into account, the girl and the boy sitting here first. How many options do I have here for the bird 3? How many options do I have here? Okay, if the boy and the girl is out, how many people are left? 3. So how many options do I have here? 3. Then, so this is 3 factorial. Now so, now how many options do I have here? 3, 2, 1. How many options? So this is going to be 2 factorial times 3 factorial. How many options do I have here? 3. Yeah? Yeah? So it's going to be 2 factorial times 3 factorial. How many options do I have here? 3, 2, 1. So it's going to be 2 factorial times 3 factorial. You say, hang on, what do I notice? Always the same, it's a pattern. Not so. And how many times is that pattern actually being repeated? Sorry? 4 times. So it's going to be times 4. So in other words, this sum here is simply two factorial times 3 factorial times 4. Okay. I almost think it's 4 factorial, but I'll check now. 2 factorial times 3 factorial times 4. So there's how many ways can that happen? 48 ways. Let's check if that answer is correct. Should be. So 48 ways. Okay. But imagine there was now 9 people or 15 people in the room. And this girl and this boy now forced to sit together. Imagine, are you going to now go through all this craziness? No. So we must actually now come with a easier way of looking at this, okay? So what we do is we say, okay, go back and remember that answer was 48, no? You say, okay, if this is a boy and a girl, not so, if the boy and his girlfriend sitting together. So how many ways can they sit together? 2 factorial ways, not so. So now we consider this to be one entity now. Can you see that? So it's going to be 2 factorial. Now this is now 1 bit. So how many options do we have? 1, 2, 3, 4. So you just multiply this by 4 factorial. Okay. So 2 factorial times 4 factorial also gives you 48. Okay. So how do we look at this? We say, okay, it's 1, 2, 3, 4, 5. The boy and the girl we bind. They're bounded now. So they can sit in how many ways? 2 factorial. Multiplied by, this now is 1 bit. 1, 2, 3, 4. 4 factorial. And that's how we get 48. Okay, you guys understand? Right. Sounds a bit confusing. You guys are not convinced yet. Right. Let's look at in the next question. In C, we are told, let's take this out. Okay. C, we are told in how many ways can they sit in a row if the boys and the girls are to sit together. Okay. So how many seats do you need to allocate for? Or how many bits do we need? 5. Still 5. So if the boys have to sit together, how many seats will they occupy? 3. So we bind the boys. We put there a bow around him, no? How many ways can they sit? Sorry? 3 factorial ways, not so. Because for the first seat, of the 3, you got 3 the options, then 2, then 1. Okay, that girlfriend is getting the best sleep of her life. You okay? Tell her I'm talking to her. Yes? I'm talking to her. Are you okay? You're not sleeping. You know this work. Are you listening, not looking? Ha! Are you new to this course? You new here? Strange. Okay, so what are your options here? Go. Not so. So they're sitting in how many ways? 2 factorial ways. Did they specify boys must sit first? And girls must sit first? So this could also interchange. So multiply that by 2 factorial ways as well. You guys understand? So again, the boys have to sit together, it's 3 factorial. The girls have to sit together, it's 2 factorial. And this of course can interchange, it's 2 factorial. So that will give you 3 factorial times 2 factorial times 2 factorial. You didn't have to put 2 factorial because that 2 factorial is the same as 2. So that's 2 times 1. Yeah? Give me an answer of 20. Am I moving too fast? No. Oh, I'm moving too slow then. So that's the reason why that girl don't need to look. Let's look at D. How many ways can I sit in a row if just the girls have to sit together? You know the girls in the stage. Probably girly girls, no? So how many bits do we have here? 5. Alright. How many girls are there? 2. So the girls can sit there, or there. Not so. So what do? I bind them. So how many ways can that girl sit together? 2 factorial. Multiplied by how many bits are there now? This is now 1 bit. Not so. So it's 1, 2, 3, 4. It times by 4 factorial. Which is 48. We did that calculation already. Okay. Is there any confusion? Isn't it? Yes, okay. Hesitating there for a bit. The stuff is nice, man. Easy. That's why we're doing it so early in the year. So we can get us marks. Huh? So I don't know what that means in sequence and series. Normally sequence and series is the section that people nail. No? Because that's easy. But okay. But it's easy for one, not necessarily easy for another. People here we are told in E. In how many ways can they sit in a row if just the boys have to sit together? That's not normal. Okay, but okay. So how many bits must we have? 5. So we have got boy. So we bind them. Not so put a bow around them. So how many ways can they sit? 3 factorial ways. Not so. Times. So this now becomes 1 bit, 1 entity. So I count 1, 2, 3. In other words, they could sit there, or there. That's how I'm getting 3. No? You bind that boys together. So it's going to be multiplied by 3 factorial, which is 36. Let's look at F. In how many ways can they sit in a row if the boys and the girls are to alternate? That sounds more like it. So it's 1, 2, 3, 4, 5. Can I start with the girl? Yes, she says yes. Okay. Girl then must come. Boy then. Girl then. Then what? Boy. Are they alternating? No. So can this be a case? No. The boy has to sit at the end because there's an odd amount of boys. Not so. There's more boys than girls. So we start off with a boy, girl, boy, girl. Not so. Now considering where the boys are sitting. Considering where the boys are sitting. How many ways can the boys sit on those places? 3 factorial ways. Not so. How many ways can these girls be seated on its places? 2 factorial ways. Which is 6 times 2, which is 12. People, you guys understand? You guys understand? Is there any confusion here? Any confusion? Okay. So with that, you should be able to do exercise 3 on page 315. Okay. Okay. It's very important for the lesson on Monday.